Welcome to Cloud Events with Google Cloud. My name is Grant Timmerman. I'm an engineer on Google Cloud, where I primarily work on serverless and open source. In the next 25 minutes, we'll be talking about the rise of microservices in serverless computing, the Cloud Event specification, an industry standard for communicating events between services, events for Cloud Run, how you can deliver events directly to your applications, and finally, we'll be showing the developer experience, along with a demo. First, let's give a background to event-driven architectures by talking about the rise of microservices. Why microservices? Well, it's easy to describe with an example. Here we have Bob's big bad monolith with these effects. Your application has global state, increasing complexity. There's often a complicated orchestration with non-uniform communication between services. There's group scaling, with services scaling up based off of demand of one part of a service. Couple dependencies, with library dependencies applying to all services. And it's often difficult to test, heavily requiring mocks, slow, often closed source. So in effect, your application does not follow the single responsibility principle and can sort of be described like a Swiss Army knife. That's compared to Mary's orchestrated microservice, where we have the following upsides. You have local state with reduced complexity, a request and response model where you have clear boundaries of ownership, only pay when receiving an event, individual scaling and loose binding. Dynamic demand can increase service capacity independently of each other. Local development and testing is quick and easy, and you can easily configure access management with granular security per service. We're in a world where applications are moving towards real-time communication. Well, what does this mean? It means rapid delivery and consumption of services. So event-driven architectures often require immediate responses. You have many-to-many messages where modern applications expect to produce and consume many events from a variety of sources, as well as a desire for on-demand scalability and cost, where modern applications see dynamic traffic, but really expect to see decreased costs. So once you have decoupled microservices, how do these microservices communicate with each other? Well, through events. What is an event? In programming, an event is an action or occurrence recognized by software. It often originates asynchronously from the external environment. The publisher of the event has no expectation about how the event is handled. The consumer of the event decides what to do with the notification. And events are discrete units. They're isolated and independent from each other. What is an event-driven architecture? Well, it's based off of indirect notifications with an intermediary or broker. You can deliver the full event data or just a reference to the external location where the event can be found. This is compared to direct polling between different services and service-oriented architectures providing direct access to APIs. Well, you can't really create a real-time system this way. At least it's very hard. So events make applications complicated. But in practice, developers simply want to make applications work and not really think about conceptual eventing systems. Managing events is important, but cumbersome. As a developer, you have questions like, what happened? What type of event did I get? Who sent the event? Where is the event from? When was the event sent? Is it a duplicate? Is it created recently? And moreover, every event has its own different format. What if there is a common machine-readable standard for events? Well, introducing the CloudEvents specification, a common way for describing events. So here's the premise. Events are everywhere, yet event publishers tend to describe events differently, especially with respect to versioning, payload formats, and subtle payload differences that may break your application. So Cloud Events is the specification for describing event data in a common way. It's brought to you by the Cloud Native Computing Foundation Serverless Working Group, a group of developers across the computing industry creating standards for more compatible services. At the core, Cloud Events is an envelope for information about the occurrence of change in the system. I like to think of it like a one-way letter with a from address and no to address. The Cloud Event format has the following properties. The Cloud Events carry facts and metadata with standard attributes. They do not prescribe what you do with these facts. They're self-contained, meaning you don't need to attach any information to the event. It gives the whole picture. The event format itself is lightweight. They're unique within a source. You can encode them in different formats without losing or modifying information, such as JSON, BSON, Avro, etc. And doesn't talk about any HTTP methods, API surfaces, just talks about the HTTP mapping. I think it's really easiest to understand Cloud Events by seeing some examples. So let's say we're a web application on top of GCP. Here we have some example events that you might see in your application. A new photo is uploaded, a new generic message is published to a topic, maybe a new user, or a new audit log is recorded. Whenever maybe a new VM is spun up in a project. These are different events you might see. So as a developer, I have some questions about, well, the event being delivered to my system. Well, what kind of event did I get? When was it sent? Who sent it to my service? What's the event's unique identifier? What's the shape of the event data? And what is the event data? Well, this corresponds to the following Cloud Event fields of type, time, source ID, data schema, and the data fields. Now, if we fade out the questions and left align the properties, use font Courier new, and specify the version of the payload with the spec version property, add some data, you get a Cloud Event. This is an example of Cloud Event that you might see from PubSub. So more about the spec can be seen on GitHub. Let's dive deeper into that specification. Every Cloud Event has a set of required and optional attributes. Here are 4 required ones with some examples. You have the ID, which is a string, identifies the event. The source plus ID must be unique. The source is a URI, identifies the context. The spec version is a string. The Cloud Event spec version to be used with that event, like 1.0 or 0.3. Then you have the type attribute, which is a string, a value identifying the type of event. And the Cloud Events may have some optional attributes in this format. Well, you can have data, well, it can be anything. It's domain-specific information about the occurrence. A data content type is a string. The MIME media type, RFC 2046, such as application JSON. You have your data schema, which is a URI that identifies the schema, the data attribute. In Google's case, we use prose. Subject is a string. This is the subject of the event. It's really useful for filtering. And time is a timestamp, the time of when the occurrence happened. Other attributes are allowed, but just not standardized. There are 2 primary modes for encoding Cloud Events sent via the HTTP protocol. You can use binary encoding or structured encoding. These are called content modes in the Cloud Event specification. Let's go over them. Here on the right-hand side, you have an HTTP request with the Cloud Event using binary encoding. At the top, you see an HTTP post to slash with some standard HTTP attributes. There's some context attributes with the HTTP header prefix of CE dash. Feel free to add other headers too. And then you have the Cloud Event body, which is the full HTTP body. This encoding is used by Events for Cloud Run. That's compared to structured encoding, where we have the context attributes under the first level properties of the JSON object, and the data attribute under the data property. This encoding is used by Cloud Functions, for example. So what does this look like in practice? Well, your service will receive an HTTP request. Within that HTTP request is a Cloud Event. And then within that Cloud Event, you have some metadata, these Cloud Event standard attributes, and your event payload. So that's the Cloud Event. It should be very clear what a Cloud Event is. So let's go and move on. Now let's talk about events for Cloud Run. Cloud Run is a fully managed computing platform for deploying, scaling, containerized applications quickly and securely. Use any language, abstract infrastructure management with a simple developer experience. It's built on the Open Knative standard. Events for Cloud Run makes it easy to connect your applications from a variety of sources, and it takes care of event integration, delivery, security, and authorization with error handling for you, which all in all improves developer agility and your application's resilience. The long-term vision is to be able to deliver events from a variety of sources to Cloud Run and custom syncs. Currently, you can deliver events from Google Cloud sources via Cloud Audit Logs or PubSub to Cloud Run. So going back to the event examples we had described before, whenever a new file is uploaded to Google Cloud Storage, new message is being published to PubSub, or a new audit log is created, you can now trigger Cloud Run services directly from events via events for Cloud Run. The way events for Cloud Run works is like this. You can trigger your service from a variety of sources, Google Cloud Storage, PubSub, Cal, and your events will go through events for Cloud Run. Then this will send an HTTP request to your Cloud Run sync with a Cloud Run payload. Let's break that apart. On the left, you have some event producers, our sources. With sources, you can describe the event sources, you can describe the event types, just describe all the event types. In the center, you have a Cloud Run service where you can go and manage your triggers. You can create new triggers specifying the event source. For example, cloud sources via Cloud Audit Logs, or custom applications via PubSub. And you have your CRUD operations for triggers like listing triggers, deleting triggers, and describing triggers. These triggers specify your sync, which is your Cloud Run service, specified by name. There are three modes of interaction for configuring events for Cloud Run. You can use the Cloud Console UI, Cloud CLI, or REST API. Let's go over them. So the Cloud Events for Cloud Run UI allows you to easily create triggers just on console.cloud.google.com. Simply specify your event source, create, and done. Currently, you'll be using the Cloud CLI. After installing the alpha components in gcloud, just type gcloud alpha events to get started. Zooming into the alpha events command, we specify the trigger name, the target service, and the event type. And we have some optional parameters used for filtering, like the service name, method name, and resource name. In this case, this is a command used for Google Cloud Storage. Lastly, you can use the Cloud Run API if you really want. You might be asking, what's the difference between Cloud Run for Anthos and fully managed? Well, what's the difference? The differences are here. In summary, fully managed has a simpler trigger setup, is Google managed, but has fewer event sources currently, and you can only trigger Cloud Run services, not any Kubernetes service or arbitrary URLs. TLDR, use events for GKE and using GKE. Next, we'll be running through the developer experience and some useful tools when using events for Cloud Run. First up is the Cloud Events SDK. The Cloud Event SDKs are a lightweight set of libraries designed to speed up your integration with Cloud Events within your application. They can do three things. You can create Cloud Events, send Cloud Events, and receive Cloud Events, a language idiomatic way. There's a spec on GitHub. Practically speaking, this means that you can transform your HTTP request from this to this, extracting the Cloud Event object. These SDKs are available in the following languages: in Node, Go, Python, Java, Ruby, PHP, and .NET. Their code is open source on GitHub. And here's a little disclaimer. I can use these images, trust me. So within a Cloud Event, each event type has its own data format. So what's the structure of that data? Well, we've described the source of truth for the structure of the data in proto-ops. These protobufs contain the cloud event type, which is a string, and the cloud event data, which is the full message description. On the right-hand side, you can see an example of a protobuf used for cloud pub/sub. These have been published on GitHub, and we'll be adding more event types as new events are supported. Based off the source of truth, as mentioned, we have language and code bindings in 7 different languages. These provide types like structs in Go, TypeScript interfaces in Node, POJOs in Java. In terms of getting started, we have a set of quick start samples in these languages, as well as 2 sample applications and a code lab. Let's say we're a movie studio recording a lot of audio. We have hundreds of audio files being recorded every day. How can we search through these audio files and find the text in these files being spoken, maybe in real time? So the idea is whenever I upload an audio file to Google Cloud Storage, then let's use Cloud Speech to Text to extract the text from the audio file and then add the result to Google Sheets. Let's go to VS Code where we can see the demo. Now we're going to show a quick demo and then dive into the code. On the left-hand side, we'll see Google Spreadsheet, and on the right-hand side, we'll see a Google Cloud Storage bucket. I'm going to pass some files and upload them into our Google Cloud Storage bucket. And so there's some audio files of me speaking Chinese and English. And so you'll see on the left-hand side, we have uploaded these files and it's been added to our spreadsheet. In fact, all the audio has been recognized and transcribed into text. So like 你是谁?你是哪里人? etc. So that's really cool. How did we do that? Well, let's go dive into the code. So we use events for Cloud Run. But first, let's talk about our Cloud Run service. So we provided a Docker file, just specifying our base image of node 14, and we're going to and from start. We're just creating an Express app. Here we have just @ health check, and then / for post request, we extract the cloud event from the HTTP headers, and then we get the bucket name and the object name from the cloud event subject, and then we use those bucket and object names to get the actual speech. So what this is doing is it's calling this file speech.as and calling the speech to text function. So it's a bucket and the file name. It downloads the file and then it reads the file locally in audio bytes and base 64. And then now we're going to prepare our request to the Cloud Speech to Text API. So we're going to provide the audio bytes. We're going to provide linear 16 encoding since this is a WAV file. We're primarily trying to understand Chinese, so our language code is ch-cn, but we also want to recognize English, and so we provide the alternate language codes of English. Then we call the API, we join the result, and then we just want the actual string and we just return that. Next, we're going with that result, we go and add a new row. So how do we do this? Well, we have a different file, sheets.js. We provide a spreadsheet ID. And here we have an add row function. So here we use a service account credentials. We have a local file we downloaded, creds.js, and we provide the spreadsheet scope. We've already shared the Google spreadsheet with this service account email. So it has access to that spreadsheet that's private. And then we append some values. So with that spreadsheet ID, the range isn't really needed. We're going to provide a 2D array of value, which is just an array of our results. And so we just append the values, and then we say 200 OK to the Cloud Run API. We're all good. And that's it. Now, how did I create my trigger? Well, you can see Cloud Run. It's really great how triggers are separate from your service so that you can create and delete triggers without having to redeploy your whole service. So we can see here that if we go and list all of our triggers, we have a trigger here set up. And in fact, we can go create one like I was doing before of simply creating a new trigger that's separate. Maybe we want to make a separate trigger this, and then it's really quick and easy, in my opinion at least. It takes like 2 or 3 seconds, and then it works. So sometimes it takes a little bit longer, but done. And that's how you create a trigger. And you can list all your triggers. So that's really the demo. Hope you liked it. I think my Chinese college professor would be proud. And thanks. What we just saw was a demo of deploying a Cloud Run service, creating an event trigger. We uploaded some audio files, a Google Cloud Storage bucket, which then fired an event, creating a request to Cloud Run, which uses the Google Speech to Text API plus the Google Sheets API. So in summary, we talked about the rise of microservices, the Cloud Events specification, events for Cloud Run, and a demo experience. Sign up for private preview today. Here are some links to sign up for Cloud Run and Cloud Run on GKE. Public preview is in September 2020. Thanks so much. My name is Grant. You can tweet at me at Grant Timmerman on Twitter, or check out my code at github.com/Grant. Don't forget to smile all right, and I hope you have a fantastic next